Salesforce does it all and we don't really need to worry about it, don't we? It's one thing to rely on Salesforce and quite another to understand what you're dealing with. Hey everyone, today we will touch on the architecture called Lightning Web Security, which is well known to all of us as a replacement of Lightning Locker, which provides better performance, more range of actions, and perhaps even better protection. This architecture was introduced in summer 23 and presented a design that was compliant with the new TS39 standards. We can think of it as a set of international practices and approaches for ECMAScript aimed at enhancing security, performance, or simply introducing new ways of thinking. This specific proposal's TS39 represented a really interesting concept to achieving virtualization, that is dividing a single browser context into separate, encapsulated, and protected containers. But before we move on to this new architecture, let's remember how Lightning Locker works. In essence, it makes sense to rename it to say Lightning Wrapper, since the main idea was to take, for example, the global window object that you have on the page and wrap it in some secure window. This wrapper will already define what you can change or get, what you cannot, etc. Let's take a look at this wrapper concept in practice. So that's our application, and here I added a custom parent element that contains a child element inside presented as a text right here. When I click on the button, what I do is query our child DOM element and display it in the console. I have Lightning Locker enabled right now, and as you can see, I got not a native HTML element which is supposed to be, but a wrapper called secure element. This is the basic idea of this older framework. Wrap, wrap, wrap. And another protection measure is that these two components, parent and child one, and actually all of those, are placed in one C namespace container and separated from other namespaces like Lightning. To be fair, the idea of isolation components into namespaces, like separating and executing components on the same page in different encapsulated environments, also exists in Lightning Web Security. However, the really key difference between Lightning Web Security and Lightning Lockers is that Lightning Locker uses custom wrappers and generally a lot of custom Salesforce behavior and code, while Lightning Web Security is standard compliant, has no wrappers, and mostly uses native browser behavior. Nevertheless, Lightning Web Security. We clarified that Lightning Web Security does not use wrappers. That is, if there is a global element window, it remains an element called window and not some custom, incredibly, elegantly, comprehensively secured wrapped window, as in Lightning Locker. As for separating your components into namespaces in order to secure, isolate, encapsulate, Lightning Web Security does a very good job of following the TS39 standards. The key proposal of these standards was to create a mechanism for executing JavaScript code in its own shadow realms. That is, a realm, a term that everyone understands but no one can explain, is actually the environment for executing your JavaScript code. By default, if you have a page, it's one realm, meaning one host environment. The proposal is to implement something like this. You create a new shadow realm for, in our case, a namespace, and do whatever needs to be done as part of that environment, resulting in isolation of that namespace and environment from any others that will be created. And also, your page will look like one common structure. All the namespaces will be in their own realms and will actually be limited from communicating with each other or with the global host. These environments or realms are referred to in the Salesforce documentation as sandboxes. One sandbox for your custom components and each sandbox for any other namespaces in your organization. The only question left is, how do they communicate with each other? Meaning, for example, you have your custom component that nests a component from another namespace. They somehow communicate and pass data to each other, right? Absolutely. Let's say we have a global window object. In this case, assume that this window object is represented here as a solid blue X icon, which will obviously be owned by the global host environment, as you can see on the image. And yet, your custom component can get an access to the global window object somehow. How? This is implemented using JavaScript proxy objects. Long story short, it's a wrapper that wraps your window object and determines what you can and cannot update there. I must have been hasty when it says that Lightning Web Security does not use wrappers, but an important note is that these are not some custom Salesforce wrapper, but a default object in JavaScript. Anyway, keep going. In your namespace, you don't work with the global and original window object, but only with its proxy objects, which is illustrated here as a dashed blue icon. This proxy object contains a number of restrictions on what you can change in the original window object, what you cannot. And if you try to change something that is not allowed, you either get an error or these changes are applied only in your namespace and do not propagate further to the global and original window object. This idea with proxy objects will also be followed for exchanging or manipulating objects between different namespaces, not only namespace and host environment, right? But you know what? This approach with proxy objects has one significant drawback called performance. And although we are used to calling Lightning Web Security faster, this is not always the case. Because of those proxy objects, your data or modify request has to go through a long chain before it gets to where it needs to be. And this becomes a problem when you operate over a large amount of data. What do I mean? Let's take a look at this part of code where I'm getting data from Apex. It doesn't matter if it is wire adapter or an imperative call as we have right here. The data that's received, this one, will not be part of your namespace. No, it will be owned by the global host in the browser. Just like we just looked at this diagram where window was represented as a solid blue X icon under the host environment. Only in this case, it will be your array of data, and your namespace will only receive a proxy object of its data in the form of this dashed blue X icon. What does this mean? Every time I process this array, let's say I'm going through the array and checking if the records are valid or not, I'll be operating on the chain proxy object target object. And if it is a large data set, the performance degradation will definitely be noticeable. What do I mean by noticeable performance degradation? Let me add before processing the array console time and after console time end. It will create a timeline to check the performance. And also for the purity of the experiment, I will comment out the for each directive in the markup so that we really check only from the perspective of the JavaScript processing. Now I'll open our Find the Guilty application and I'll go to the browser developer console, performance tab, and start tracking. And then we reload a page and stop our tracking. Wait a little bit. Here we are, and let's find this timing that we added using console time. Where it is? Here you are. And as you can see, it took 14.57 milliseconds to process this part of code. Not as bad, you might say. Yes and no. For comparison, let's go back to Setup, Session Settings, and disable Lightning Web Security. As soon as we disable it, the Lightning Locker will start to be used. And now let's go back to our app, reload once, and do the same thing. Go to Performance, start tracking, reload a page, and turn off tracking. Let's find out our time frame. Here it is. And as you can see, for Lightning Locker, it took 1.54 milliseconds. And I'll add to the screen the previous result from the Lightning Web Security. And if you compare, the difference, wow, it is significant, as this is just one trivial piece of code. As I mentioned, the reason is that we operate on this data through the proxy object, and going through this chain is going to take some time, a lot of time actually. But there is a way to optimize this behavior. What I can do is, instead of operating on the host data directly as I do right now, so I just got an array of records, assign it to the variable, and I operate over this array of records. What I can do is create a copy of its array using JSON parse and JSON stringify, like that. In this scenario, you create a new variable already in your own namespace and avoid using the proxy object to access the host environment. You don't care about a host environment anymore. You have this copy of the array in your own namespace. But I'll be honest, here's the result I got using this approach. 85 goddamn millisecond. And yes, these numbers may vary as I reload a page multiple times, but this cloning operation, JSON parse, JSON stringify, will always be slower than using the proxy object directly as we did in the first place. This is because this cloning operation right here is expensive. And if you need to update the array once and you're not gonna touch it anymore, using the original variable aka the proxy object would be better in this case. But let's leave this cloning operation outside our timeline, somewhere around here, and check the actual for loop processing. Same, let's go back, reload the page once, run the performance test, reload the page once more, and stop the tracking. Here it is, let's find my timeline, and look at this, it's not even a millisecond, it happened kind of instantly. And the explanation for this is also the array cloning operation is expensive. All your functions that will operate on this cloned array down the road will do it as fast as possible. That is, Lightning Web Security is slower in practice. Maybe for simple applications it will not be noticeable, but for larger ones you will definitely feel it. To sum it up, we have to pay for good architecture. Development in our time is a little different. We realize that the benefit of well-structured code that facilitate maintenance and extension are much more important than some milliseconds in performance. And you know what? I agree. See you soon.